Imagine spending, like, months building this massive, state-of-the-art data skyscraper for your company.
Oh yeah, massive undertaking.
Right. You've got millions of rows of data flowing in perfectly, but then you watch the entire system just, like, grind to a halt. Or worse, it just collapses completely.
And it's usually just because you misunderstood how memory limits work in your capacity settings.
Exactly. It's wild. And it happens more often than people want to admit.
Oh, absolutely. Because, when you're building physical skyscrapers, you have visible steel beams, right?
Yeah, you can literally see the foundation.
Exactly. But in the world of analytics engineering, specifically within Microsoft Fabric, that structural landscape is entirely digital. It is like the absolute definition of invisible architecture.
And if you don't know what you're looking at, that invisible architecture can feel incredibly murky. So today, we are making sure your data skyscraper stays standing. Welcome to the deep dive.
Glad to be here.
Our mission today for you listening is demystifying the DP-600 exam, because this is basically the gateway to proving you actually know how to build in Microsoft Fabric.
All right. And to pass it, you need a really solid grasp of the foundational concepts and, the key technical criteria.
Because it is a role-based certification, right?
Yeah, exactly. You get 100 minutes to tackle 40 to 60 questions. And they mix it up with multiple choice, drag and drop, and full case studies.
And what's the passing score?
The magic number to pass is 700 out of 1,000.
Got it. But because it's role-based, you can't just memorize what a button does. I mean, you have to understand the architectural why behind everything.
You really do.
So today, we're giving you a step-by-step analysis of 10 practice questions. We are going to read the full text of every question and then give you a detailed, item-by-item breakdown of all the options.
Right, A, B, C, and D.
Exactly. To explain exactly why each one is correct or entirely wrong. So let's get right into it.
Sounds good. And the foundation of any analytics project is how the data is stored.
Right, the storage layer.
Yeah, if you don't organize it right at the storage layer, literally everything built on top of it will suffer.
Exactly. Okay, listen to this scenario regarding storage optimization. Here's a question. What is the primary purpose of applying V-order to delta tables in a Microsoft Fabric lakehouse?
Okay, classic DP-600 question.
Right. And here are the options. Option A, to automatically delete historical data files that are no longer needed. Option B, to optimize the sorting and compression of Parquet files for faster analytical reads. Option C, to enforce row-level security policies at the storage layer. Or Option D, to convert standard CSV files into the Delta format during ingestion.
So what's fascinating here is how Microsoft handles performance under the hood. Option B is actually the correct answer here.
Okay, so B, to optimize the sorting and compression of Parquet files for faster analytical reads.
Exactly.
It almost sounds like Marie Kondo in your digital suitcase.
Oh, I like that.
You're folding all the data so perfectly that when you need to find one specific data point, you can just grab it instantly without unpacking the whole bag.
That is a perfect analogy, yeah. V-order is a right-time optimization. It literally physically aligns the columnar storage layout of Parquet files.
Wow.
Which massively reduces the input-output operations required when a query engine goes looking for data.
I was actually initially drawn to Option A, though, the one about automatically deleting historical data files, because that sounds like an optimization, right?
It is an optimization, definitely, but it's a completely different process called vacuuming.
Oh, vacuuming. Okay.
Yeah, vacuuming removes old, unneeded files. V-order is just about how the remaining files are sorted and compressed.
That makes sense. What about C, enforcing row-level security?
So option C is a really common trap. People hear lakehouse and they immediately worry about security.
Right.
But V-order doesn't enforce row-level security. Security is handled at the SQL endpoint of the semantic model layer, not by, file sorting.
Okay, so that leaves option D, converting CSVs to Delta format during ingestion.
Also wrong. Fabric certainly has tools to convert CSVs, but V-order is applied to the Delta tables after the fact. It's not the actual ingestion conversion tool itself.
Got it. Okay, so now our data is neatly packed and compressed in those Parquet files. We want to query it blazingly fast.
Naturally.
So listen to this next scenario. Which scenario will force a DirectLake semantic model to fall back to direct query mode? Option A, the query exceeds the available memory limit of the capacity. Option B, the underlying Delta table is partitioned by date. All right, so the correct answer here is A. The query exceeds the available memory limit of the capacity.
Okay, so A.
Yeah, because DirectLake's entire superpower relies on loading data directly into memory for maximum performance.
Right.
If the engine hits a memory ceiling and simply cannot materialize the data in RAM, it has to pivot. Wait, so if it runs out of memory, the whole dashboard doesn't just crash, it gracefully degrades into a slightly slower mode.
Exactly.
How does it actually do that?
It's built to prioritize query completion over failing entirely. When it hits that memory limit, it dynamically switches back to direct query.
Wow.
Yeah. It stops trying to hold the data in memory and instead fires off a SQL query directly to the storage layer to grab the data on demand. So it's slower, but the user still gets their report.
That is incredibly smart architecture. So why wouldn't the other scenarios trigger this fallback? Like option B, partitioning a delta table by date.
Because partitioning by date is standard best practice for large tables.
Oh, okay.
Yeah, the engine fully expects that. It absolutely does not trigger a fallback.
What about option C? It mentions relationships based on a string column.
Right. So while string relationships are heavier, and honestly, they aren't always ideal for performance compared to integer keys, a string relationship alone won't break DirectLake's memory loading and force a fallback.
Okay, and option D. Being on a trial capacity, I feel like trial capacities always have weird limits.
They do, but trial capacities fully support DirectLake. The trial status itself doesn't force a fallback, only the strict memory limits within whatever capacity you're using.
Got it. So DirectLake is basically the gold standard for reading massive amounts of analytical data.
Absolutely.
But what if your engineering team is actively writing data and they need multi-table transactions?
That changes things.
Right. Check out this requirement. An engineering team needs to build a solution that requires multi-table transactions and rigorous enforcement of relational constraints. Which Microsoft Fabric architecture is most appropriate for this requirement?
Let's hear the options.
Option A, a data flow Gen 2 connected to a Power BI semantic model. Option B, a lakehouse using the default SQL Analytics endpoint. Option C, a data warehouse with native T-SQL support. Or option D, a Spark notebook writing directly to Delta Parquet files.
Okay, where does your mind jump to first?
Well, I hear engineering team and writing data, and my mind immediately jumps to Spark notebooks, which is option D, because Spark is incredibly powerful. Why can't I just use a Spark notebook to enforce my foreign keys?
Because Spark really isn't designed for that.
It's not.
No, I mean, Spark is a distributed compute engine. It's amazing for massive data transformations and bulk processing.
Right.
But out of the box, it does not inherently enforce traditional relational constraints like primary and foreign keys across multiple tables.
Oh, wow. Okay.
Yeah. If you need rigorous, multi-table transactional guarantees, the correct answer is C. A data warehouse with native T-SQL support.
Okay, so the data warehouse is where we get those classic ACD properties, right? Like atomicity, consistency, isolation, durability.
Precisely. A Fabric data warehouse provides full ACD transactional support across multiple tables.
Makes sense. Let's look at the other options then. Option A was Dataflow Gen 2.
Right. Dataflow Gen 2 is an ingestion and transformation tool. You wouldn't use it as a storage engine for transactional workload.
And option B, the lakehouse using the SQL Analytics endpoint.
That endpoint is specifically a read-only interface.
Ah, right.
It does not support the transactional rights requested in the prompt.
You know, that actually transitions perfectly into our next scenario because I really want to double-click on that read-only limitation you just mentioned.
Let's do it.
Okay, listen to this question. Which action is strictly prohibited when interacting with the SQL Analytics endpoint of a Fabric lakehouse?
Read the options carefully.
Option A, creating standard database views over existing tables. Option B, writing cross-database queries linking to another workspace. Option C, modifying the underlying data using data manipulation language statements. Or option D, assigning object-level security permissions to specific database roles.
Okay, what are you thinking?
Well, since you just said it's read-only, we have to be looking for the action that tries to write data, so that has to be C.
Spot on. C is correct. Modifying the underlying data using data manipulation language statements.
Also known as DML, right?
Exactly. You cannot run insert, update, or delete operations via the SQL Analytics endpoint. If you want to modify the data in a lakehouse, you must use Spark or other data engineering tools.
Meaning options A, B, and D are perfectly valid things you can do, which makes them the wrong answers for a question asking what is prohibited.
Exactly right. Option A, creating views, is highly encouraged to organize how users read your data.
Yeah.
Option B, writing cross-database queries is a major, heavily advertised feature of Fabric. It allows you to link workspaces seamlessly.
That's a great feature. And option D, assigning object-level security.
Absolutely critical.
Mm-hmm.
And fully permitted to secure your read-only data.
All right, so our storage foundation is totally solid at this point. But before the data reaches the end user, we often need to transform and move it, right?
Yes, the data engineering phase.
Exactly. Listen to this question regarding data engineering. In the context of data flows Gen 2, what is the defining characteristic of a staging query? Option A, it bypasses the Power Query engine to execute natively in Spark. Option B, it is automatically published as a semantic model for report creators. Option C, it loads intermediate transformation results into internal storage to improve downstream performance. Or option D, it dynamically applies data masking rules based on the active user identity.
The correct answer here is C. It loads intermediate transformation result into internal storage to improve downstream performance.
Okay, so C, I always think of staging queries like a chef prepping ingredients in a commercial kitchen.
Oh, how so?
Well, you chop the onions and put them in little staging bowls before the dinner rush, right? You wouldn't pull out a whole unpeeled onion and chop it from scratch every single time a waiter rings in an order.
I love that analogy. It's so true. You process the heavy data once, you store it temporarily in Fabric's internal data lake, and then you reuse it across multiple downstream queries.
Which has to save massive amounts of compute.
Oh, absolutely. Now, looking at option A, does it bypass the Power Query engine? No. Staging queries are very much evaluated by the Power Query M engine. They don't bypass it for Spark.
Got it. What about option B? Does it automatically publish as a semantic model?
Definitely not. A staging query is an intermediate data flow step. You still have to deliberately output your final data to a destination and then build your semantic model on top of that yourself.
Right, it doesn't do it for you. And option D, the data masking.
Incorrect. Because applying dynamic data masking based on user identity is a security function handled much later in the architecture, usually at the SQL or semantic layer, not during a data flow Gen 2 staging query.
Okay, so the ingredients are prepped. Let's talk about those semantic models now.
The fun part.
Making sense of the data for the business without creating a bloated, inefficient mess. Here is the scenario. What is a primary architectural benefit of implementing calculation groups in a complex semantic model?
A very important topic for the DP-600 exam.
For sure. Option A, it drastically reduces the number of redundant measures needed for time intelligence calculations. Option B, it allows direct write-back capabilities from the report visual to the underlying database. Option C, it automatically converts a star schema into a highly denormalized flat table structure. Or option D, it enables the physical partitioning of data across multiple geographic regions.
So what's your take on this one?
Well, I read calculation groups, and it sounds exactly like the don't repeat yourself or DRY principle from software coding, just applied to Power BI.
That's exactly what it is, which makes option A the correct answer. It drastically reduces the number of redundant measures needed for time intelligence calculations.
Because without them, you'd be writing a million measures.
Literally. Think about it. Without calculation groups, if you want year-to-date, month-to-date, and year-over-year calculations for revenue, profit, and costs, you have to write 9 separate DAX measures.
Which is an absolute nightmare to maintain.
Right. With calculation groups, you define the time intelligence logic once, and you can apply it dynamically to any base metric. It's incredibly elegant.
Let's talk about the distractors. Because option B sounds like an actual magic trick. Direct write-back capabilities from a report visual.
It would be magic, yeah, but it's completely false. Calculation groups strictly calculate values for display using DAX. They have zero ability to write data back to the underlying database.
Shocker. What about option C, flattening the star schema?
Wildly incorrect. Calculation groups do not flatten star schemas. In fact, best practice is to rigorously maintain your star schema.
Don't mess with star schema.
Never. And option D is completely unrelated. Calculation groups handle analytical logic. They have absolutely nothing to do with the physical partitioning of data across geographic regions.
Right. Speaking of efficiency, though, it's not just about reducing DAX formulas. It's also about not forcing the system to reload 5 years of historical data every single morning.
Oh yeah, that will kill your performance.
Exactly. Listen to this requirement. When configuring incremental refresh on a large fact table in a semantic model, what must be established first within the Power Query editor? Option A, a native database query that includes a group by clause. Option B, a many-to-many relationship with the primary date dimension. Option C, a custom function that calculates the rolling average of the primary key. Or Option D, specific reserved parameters that define the range start and range end.
This is a classic question about resource management on the DP-600. The correct answer is D, specific reserved parameters that define the range start and range end.
Okay.
And these parameters, quite literally named range start and range end, are completely mandatory.
Yet how do they actually work? Like, how do two little parameters stop the system from swallowing the whole ocean of data?
It's all about query folding.
Oh, query folding, right?
Yeah. When you set up those parameters, you filter your date column using them. Then the Power Query engine translates that filter into a native SQL where clause.
Oh, nice.
It pushes that query all the way back to the source server. So instead of downloading 5 years of data and filtering it locally on your capacity, the source database only hands over yesterday's data.
That makes so much sense. So why wouldn't option A work? A native database query with a group by clause.
Because writing your own custom native SQL queries in Power Query can actually break query folding.
Oh, really?
Yeah. If the system can't fold the range start and range end parameters into your custom SQL, the incremental refresh will either fail or just become incredibly inefficient.
It's really good to know.
Yeah.
What about option B, a many-to-many relationship with the date dimension?
That is just terrible modeling practice in general.
Yeah.
You want a one-to-many relationship with your date table, and it certainly isn't a prerequisite for incremental refresh.
And option C, a custom function calculating a rolling average of a primary key.
I mean, that makes absolutely no mathematical or architectural sense. It's pure nonsense designed to distract you.
Just a word salad. Okay, we have a perfectly optimized model on our laptop now, but that's honestly useless if we can't deploy it safely into the wild.
Time to go live.
Yes. Let's look at deployment and management requirements. Here's the question. What is a required prerequisite for utilizing XMLA endpoints to perform advanced metadata deployments to a semantic model?
Right. What are our choices?
Option A. The workspace must be assigned to a premium or fabric capacity. Option B. The model must exclusively use the import storage mode. Option C. The underlying data source must be hosted entirely on premises. Or Option D. The user must possess a global administrator directory role.
Okay.
So, my gut says the answer is A. The workspace must be assigned to a premium or fabric capacity.
And your gut is correct.
But why? Like, why does XMLA specifically demand premium capacity? What is it actually doing under the hood?
Well, XMLA endpoints allow external tools like Tabular Editor or Azure DevOps to connect to the Fabric dataset exactly as if it were a full-blown SQL Server Analysis Services instance.
Oh, wow.
Right. And that requires dedicated, heavy-duty compute resources to manage that advanced metadata orchestration. Standard shared capacity simply cannot guarantee those resources.
Okay, that makes total sense. That eliminates A. Let's look at B. Must exclusively use import storage mode.
Wrong. XMLA endpoints work brilliantly with direct query models as well.
Awesome. And option C, the underlying data source must be hosted on premises.
Also incorrect, because the underlying data source definitely does not need to be on premises. In fact, most are in the cloud these days.
Right. And option D is the global admin role.
Which is a classic over-permissioning trap.
Yeah, sounded like a lot.
Requiring a global administrator role is massive overkill. You just need workspace-level contributor or admin permissions. You do not need the keys to your entire corporate tenant just to deploy a model.
Good. So you have the premium capacity, and you are ready to use deployment pipelines to move your code from your test environment to your production environment.
A critical step.
Definitely.
Yeah.
Listen to this scenario. When utilizing deployment pipelines in Microsoft Fabric, which artifact property is typically preserved and not overwritten when promoting content from the test environment to the production environment.
Options.
Option A, the semantic model schema. Option B, the report visual layout. Option C, the data pipeline orchestration sequence. Or option D, the workspace role assignments.
The correct answer here is D, the workspace role assignments.
Okay, let me play devil's advocate here for a second.
Go for it.
If I'm deploying from test to prod, don't I want everything to be an exact, identical copy? Why wouldn't I overwrite the roles?
Because security is environment specific. Think about it. You have a team of, say, junior developers building things in the test workspace.
Right.
If you overwrite the production roles with the test roles, those junior developers suddenly inherit access to highly sensitive live production data just because you clicked deploy.
Oh, wow. Yeah, that would be bad.
Very bad. The deployment pipeline intentionally preserves the target environment's role assignments to prevent data breaches like that.
Which is an absolute lifesaver. And I guess that explains why options A, B, and C are wrong. The semantic model schema, the report visual layout, and the data pipeline sequence, those are exactly the code and design artifacts you do want to overwrite.
Exactly. Updating those to the newest version is the entire point of pushing a deployment. You overwrite the code, you preserve the security.
Perfect rule of thumb. Now, speaking of security and roles, who exactly has the right to publish these models in the first place? Here is our final question.
Let's hear it.
Which workspace role provides the minimum necessary permissions required to publish a newly created semantic model into a Microsoft Fabric workspace? Option A, the viewer role. Option B, the contributor role. Option C, the capacity admin role. Or option D, the tenant admin role.
Okay.
Now, I know so many teams that just make everyone a workspace admin or capacity admin just to make life easier and avoid permission errors. So why wouldn't it be C or D?
Because both of those extremes create absolute chaos. The correct answer is B, the contributor role.
Okay, contributor.
Yeah. This relies heavily on the cybersecurity principle of least privileged access. Contributors have just enough permission to add and modify content like publishing semantic models without holding dangerous administrative keys that can, delete workspaces or alter capacity settings.
Okay, so capacity admin and tenant admin can publish, obviously, but they are wrong answers because the question specifically asked for the minimum necessary permissions.
Exactly. Giving a standard developer tenant admin rights just so they can publish a dataset is a massive, unnecessary security risk.
Yeah, please don't do that.
Please don't.
Yeah.
And looking at option A, the viewer role is incorrect because viewers can strictly only view the data. They cannot publish, edit, or modify anything at all. Contributor really is that sweet spot.
Thank you so much for joining us on this deep dive. Keep studying, keep exploring your data, and good luck constructing your digital foundations.